is Algebra 3, Lesson 7. It covers inductive and deductive reasoning, covers logic, covers the contrapositive, converse, and inverse. Contrapositive, converse, inverse are all things that we covered back in Algebra 2, even a little bit in geometry. So even if you haven't had geometry, I believe you still have had inverse, converse, and contrapositive, right? Yes, maybe. Okay, we're also going to be talking about the inductive and deductive reasoning. Some of these questions, they're definitely not my favorite because some of them are more like trial and error than anything else. For instance, this first question, find 3 consecutive odd integers such that the sum of the first and the third equals the sum of the second and 45. So essentially what you have, and I don't have a good set of notes on this, so let me make sense. All right, so we have odd integers. Okay, 3 consecutive odd integers. So imagine this as, A, B, and C. 3 consecutive odd integers. So that would be like 1, 3, 5, right? 7, 9, 11. 3 consecutive. They could also be odd. So it could be like -1, +1, 3. Okay, that's what we mean by consecutive. It could be -3, -1, 1. But they're going to be from least to greatest. So as I go across the number line, keep that in mind. Okay, so find 3 consecutive odd integers such that the sum of the first and the third equals the sum of the second and 45. All right, so let's see. Basically what we're saying is the first and the third, A plus C equals B plus 45. Okay? Do you follow that? Okay, first plus third equals second plus 45. So at this point, there are things that you would just kind of try. But notice that B is between A and C. Okay? And B, and you were talking about, has to equal B plus 45. So ultimately, because we're adding 2 things here and we're adding 2 things here, what I want you to understand is that kind of a hint to this is the number's probably going to be close to 45. Okay? Now, these numbers have to be odd, right? So what I would try, and I'm not looking at an answer here, but I would say, what if this was 41, 43, and 45? Let's see what that turns out to be. Okay? Well, that would be 41 plus 45. Is that going to equal the same as 43 plus 45? No, right? I can tell we don't even have to do the math yet there, right? All right, so let's try something else. A, B, and C, but they've got to be around the 40s, correct? So we could try 43, 45, and what, 47? Okay, so what about 43 plus 45? Is that going to be equal to 45 plus 45? Well, this is 90. Oh, I'm sorry, 47. This needs to be 47. Sorry. Is 43 plus 47, what is that? Is that 90? Okay, so you see how that works a little bit? But all of these are going to be different. They're going to give you different scenarios. Okay? So I always want to start off with using variables, and in setting up an equation, it's going to look something like this, at least in that form or type, where I'm taking the placement and I'm putting those in order, and I'm plugging in whatever numbers they give me on the other, wherever those things need to go, so I can see that, and then I can begin. I'm going to keep that equation. I'm just going to plug in different numbers until I get something that equals. There's not and because the equation types are different all the time, not just 1, 2, 3, repeat. If you just do these steps every time, it'll work every time. It's more of inductive reasoning. What can I see based upon this? Well, because I knew I was adding one number in 45 and I'm adding 2 numbers over here, well, in order for me to be anywhere close, the numbers have to be right around in that 45-ish range. Does that make sense? So that's our inductive reasoning there. So this is number 1. Okay, let's move over to number 2. Number 2 is kind of similar. It says 4 consecutive even integers. So A, B, C, D, and again, they can be negative. 4 consecutive even integers such that if the sum of the first and the third. Okay, well, what one's first? Okay, and it says sum of the first and the third, A plus C, is multiplied by 3. So what am I going to do with A plus C? I need to put them inside parentheses. What am I going to put outside that parentheses? 3. So 3 times A plus C, 3 times the sum of A and C, is multiplied, let's see, such that if the sum of the first and the third is multiplied by 3, the result is 14 more than. Okay, so what is that? Does that tell me that are the two sides equal to each other? No, they're imbalanced. So they're imbalanced by how much? 14. Which side is heavy? The left or the right? Are you sure? Read it again. It says, find 4 consecutive even integers such that the sum of the first and the third, if the sum of the first and the third is multiplied by 3, the result of this is 14 more than. So which side is heavy? The left-hand side. So what can I do to the left-hand side to lighten it? Subtract 14. Okay? Add to the other side? Yes, you can. It's the same thing. Okay? Yeah, the question was, could we add to the right-hand side? And yes, you can. The result is 14 more than 5 times the fourth. So what needs to go on the right-hand side based upon this? 5D. Okay? Now, I'm going to fast forward a little bit for you here. Okay? And I'm going to give you the numbers. Okay? The numbers here are, I believe, 32, 34, 36, and 38. Okay? So if you try those, we have 3 times 32 plus 36 minus 14 equals 5 times 38. Okay, and you should find that, I think that those numbers come out to 204 and 204. But you see how I need to start with this and then follow the rules, and then it's guess and check. Okay? Does this make sense so far? Like I said, you can tell now why there's not, do these orders in this order, or do these rules in this order, right? Because they're different. Okay? All right. Number 3. All right. Find a conclusion that will make the argument valid. You got a question, Geneva?
On the last question, I keep getting 190.
Did I mess up somehow? Okay. It might be because... But did you get 190 on both sides? Okay. It's probably because on my paper, I have adding 14 to the right-hand side. Okay? And in that case, if you add 14 to the left-hand side, you would get, 190 plus 14, you'd get 204, and you'd get 204 over here because I'm not subtracting 14. In either case, I still get both sides to equal each other, right? Okay? It's just, it was different depending upon whether I subtracted from the left or added to the right, but they still equal. Okay? Sorry. All right, number 3. Let's look at the question here. It says, find a conclusion that will make the argument valid. If you work hard, then you will find a position. So we're dealing with a hypothesis, okay, and a conclusion. Okay, what is the hypothesis in that statement? Okay, so if, I'm going to shorten this, work hard, okay, then conclusion is that what it says? Find position. Okay, then there's a position. Work hard, hypothesis, then conclusion. Okay, A, B. Okay, the next one, if you find a position, okay, then what? Then pay. Okay, so here is B, and this is C. right? It's a new thing, correct? All right, so what is our conclusion? We should have a final if-then statement. All right, this is what we call the transitive property. The transitive property is if A equals B and B equals C, then A equals C. Does that make sense? All right, so what is A? If you work hard, then you will get paid. Okay? That is our valid conclusion, is our final statement. Okay, that's logic. Okay, does that make sense? It's transitive. Okay, but it helps if you label the different portions. Okay, and if you see a repeated portion, it's going to keep that same letter. And you can see the relationship a little bit easier. All right, let's look. Number 4. Number 4, I think, is a multiple choice question. Number 4, select a conclusion that will make the following argument valid. If you study, that's A, right? Then you will get a good job. What is that? B. Okay. Next statement, if you get a good job, what is that? B. Then you will be well paid. What is that? C. So what do I need? If A and C. Which one is if A and C? Or if A then C? C. If you study, then you will get paid, or that you will be well paid. So C is our answer on that, right? Okay. If A then B, if B then C, then if A then C. Okay. Number 5. Okay. Does this make sense? I'm not rushing too fast for anybody. Okay. All right. Number 5. Write the contrapositive. Okay. So the way a statement works, it's if A, then B. Okay, contrapositive. Right? Contrapositive is what it wants. Okay, in order to understand contrapositive, it helps if you understand converse and inverse. Okay? Converse is if this is my statement. Okay? This is the statement. Converse is if B, then A. That's converse. Okay? Inverse is if not A, then not B. Okay? Inverse keeps the same order with my hypothesis and my conclusion, but it makes it negation. Now keep in mind, if this was if not A, then B, then down here would be the opposite. It would be if A, then not B. Okay? So my original statement can have a not in it. It's going to have to be the opposite whenever I get down to the inverse. But the order stays the same. But with a contrapositive, we use both. We switch the order and apply negation. We would say if not B, then not A. Does that make sense? So we need to understand what these things are before we can answer the question, what is the contrapositive? So our statement in the contrapositive is this. All right, and this is the law of syllogism to help determine whether the following arguments are valid or invalid. What we have here is our major premise and our minor premise. Our major premise is our first statement. Our minor premise is our minor premise second statement. So what it says there, it says all non-algebra students are not cool. That's the major premise. Neil is not cool. Okay, that's our minor. Therefore, Neil is not an algebra student. So if we look at 5, if a student is cool, then the student is an algebra student. If the premise isn't valid, then the contrapositive isn't valid. In this case, it's not valid. Okay? Not valid. If you want a good page to look at for some of this, you would look at page 57. That's where you're at. Okay? So, because this is what I want you to see, is that the major premise is all non-algebra students, okay, are not cool. Neil is not cool. If it had said Neil is a non-algebra student, then we could say that Neil isn't cool. Okay? But because it attached it to the minor premise, him not being cool, we can't necessarily assume that he's a non-algebra student. Okay? Do you follow me, or did I lose you? Could be a little tricky. Okay? The major premise is non-algebra. The minor is cool or not cool. Okay? Can you be not cool without being an algebra student or a non-algebra student? Sure. But it says all non-algebra students are not cool. Okay? Do you see how you've got a major there? Okay? Doesn't mean that other kids can't be cool, but we know this about the non-algebra students. Right? Okay? So you could be in algebra and not be cool, but all the non-algebra students are not cool. All right, I don't know if you got it or not, but in any case, it's a little tricky. All right, let's see, number 6. I apologize. In this class, we're probably going to go to the bell just simply because this stuff is a little bit harder than like Algebra 1, Algebra 2, geometry, that kind of thing. All right, number 6, write the contrapositive of the following statement. We can probably do this out loud. If a number is not divided by 2, not divisible by 2, that's my A, right? Okay, but notice it already uses negation. Then it is not even. Contrapositive, all right, is going to be this, and I'm just going to say this. If a number is even, okay, notice how I went and I used the conclusion first and made it the opposite of the statement. If a number is even, then it is divisible by 2. That's the contrapositive. Do you see that? Start at the end, apply negation. If it's a double negative, it's going to become positive. Okay? And then I'm going to go back for the conclusion. I'm going to go to the hypothesis, and I'm going to use negation. If there's already a negation there, it becomes positive. Does that make sense? You guys? Okay, so you heard that. If you had to, you go back and listen to number 6. Okay, because there was nothing I wrote on the board. Let's see, finally, number 7. Okay, find the contrapositive of the following statement. If she studies hard in math, she will succeed. So how should I start? If she doesn't succeed, then she didn't study hard in math. So we would say if she failed, then she didn't study, right? Which one of those matches that? C. If she will not succeed, okay, there's your negation, then she does not study hard in math. C is our answer. Do we feel like we got at least a touch of that? Okay, so it didn't, at least the questions covered up here didn't really deal with converse and inverse, but you have to understand converse and inverse to get contrapositive because it uses both of those at the same time, but I also want you to understand them independently. How many of you remember covering this in former math classes? You at least recall. Okay, I got 2 guys, probably from geometry though, right? And then I've got a bunch of you that are in geometry now. So by the time you get to it in geometry class, you have already been familiar with it, right? And some of you aren't in geometry, so hopefully, did you get enough of it today to hopefully be successful? Great. All right, we're going to hit stop there. You guys have, we shouldn't be putting things up. We got about 5 minutes. Let's go ahead and try to answer at least 2 questions.